All right, everybody, how we doing? We're going to take a look at the subatomic particles. We're going to look at protons, neutrons, and electrons. Look at how they interact, and look at how we look at the numbers of them and their locations in the atom. Okay, so first things first, we want to do is realize that because particles are so small, to weigh their mass in grams or kilograms would be kind of crazy. So what we do is we invent a smaller unit called the atomic mass unit, AMUs, and that describes the mass of a very small particle. This again has been changed a few times over the years, but at this point it has a fresh definition. The definition would be 1/12 of the mass of a carbon-12 atom. So what that simply means that in a carbon atom, you have typically in the isotope of carbon-12, which has 6 protons and 6 neutrons. If you had 6 protons and 6 neutrons in a little nucleus, if I drew all those little particles and I had 6 and 6 and I have 12 particles, if I divide that by 12, if I take 1/12 of that, right? If I take 1/12 of 12, that would actually equal 1. So 1 AMU basically is the size of an AMU. Okay, it's the mass of a particle in the nucleus. All right, so again, a couple things about where you find these, and I think most of this stuff you guys already know, but we're gonna look at it just briefly, really quickly anyway, is electrons are little particles that are outside the nucleus, and they surround the nucleus. Their mass is nearly nothing, so we're going to have to understand it. We're going to assume that electrons don't weigh anything. In fact, they do. They're 1/1836 of a proton, so a very small amount of mass, almost 2,000 times smaller than a proton would be. Okay, so we're going to assume in the weight of the atom that they're going to weigh almost nothing. Okay, a proton would be these little red guys here. Those guys would have positive charges. Again, the word positive proton. Okay, they have same mass as a neutron, approximately this 1 AMU weight. Okay, neutrons, again, would be in the nucleus with the protons. These are bound together in the nucleus. Okay, and again, they have neutral charges, and they have the same mass as a proton as well. In fact, neutrons are very slightly heavier on average than a proton would be. Okay, so again, what you want to think about this is that since electrons weigh nearly nothing, okay, again, nearly nothing, the entire mass of this atom is pretty much located in the center. So when you weigh atoms, we're weighing their nucleus. Okay, so that's an important thing you want to remember. Again, we're going to assume that these electrons out here don't weigh anything. Okay, and so to review, your proton is a relative mass of 1 AMU. Your neutron would also be about an AMU. And again, your electron is 1/1836 of an AMU. Okay, however, something interesting about the charges for a proton would be +1. And even though an electron has 2,000 times smaller than that, you would have a charge equal and opposite. So a proton and an electron are actually opposite charges to one another, a neutron having none. All right, so next thing is something called an atomic number and the mass number. Okay, and as we look at numbers of this, if we had to draw atoms out all the time, that would be kind of cumbersome to do. So what we normally would do now is use atomic number and mass number. And again, you've seen these kind of things before. All right, so symbol notation. And how we notate a symbol is typically what we're going to do is we're going to take the symbol of the element, and you're going to see a number above and a number below. Okay, and the top number here is something called a mass number. And the mass number is exactly what it means. It's the mass of the entire atom. Okay, and again, like we spoke about before, the mass of the atom, the whole atom, is going to be from the protons and the neutrons. Okay, now if I just gave you this number, you probably wouldn't know too much, so you kind of need the lower number, and the lower number is the number of protons. So the top number simply tells you have 2 protons in here for helium and 2 neutrons. Okay, the chemical symbol would be here, and of course the atomic number would be down here. Now the atomic number is probably the most important number here, because this is going to tell us really 3 things. Number 1, it tells us the number of protons. Okay, so this is the number of protons that goes along with helium. All right, and that defines what the element is. Okay, this also tells us the number of electrons that are in a neutral atom. Okay, again, neutral atom means really important that the protons equal the number of protons have to equal the number of electrons. And that's when you use the word neutral atom. This is a huge thing you need to know. Very, very important that you need to know that, okay, when you use the word atom. So really when you have an atomic number, the protons and electrons are going to be the same. So this would have 2 protons and 2 electrons, okay? And lastly, which is a really important concept, is that you identify what the element is, okay? So if you're 2, you're always going to be helium, Okay, always. Okay, and this number will always be on the periodic table. Okay, so on the periodic table, I always give you. Now, you can alter the number of neutrons. The neutrons can change in the same element. So, for example, you could have helium and be a 4 and a 2, or you could be helium and be a, 3 and a 2. I mean, you could be. So the number of neutrons can change, but the protons have to be the same for that element. It's really, really important to know that. All right? All right, so some general rule. Okay, the mass number, if you take the mass number minus the atomic number, you would equal the number of neutrons. Okay, so really important. So if you make a little subtraction symbol out of this, so for example, if you took He42 and you went like that and make a little subtraction sign out of that, you would get 2 neutrons. So it's top minus bottom will give you the neutrons all the time. Okay, so that's really important to know. Again, the top number is the total mass of the atom. The bottom number is just the protons. All right? So if I were to draw the symbol notation, and again, the symbol notation is going to be this notation here for an atom of sodium, which has 12 neutrons. Okay, I'm going to look up sodium in the periodic table, and I know the sodium is going to be Na. Okay, if I look up the protons, I'm going to find out the protons, the atomic number is going to be 11. Okay, so I can say 11 protons. Okay, now I know the top number is the protons plus the neutrons, plus 12 neutrons, okay, equals the number 23. So that number is going to go up here as number 23. Okay, so this would be the symbol notation. The symbol notation for sodium that has 12 neutrons. Okay, so you would have 11 protons, okay, and 11 neutrons. Okay, you can think about it like that. All right, and sometimes neutrons will have a 0 at the top because they're neutral. All right, so really important to know. You got to know how to do this. So we're gonna practice on how to do that a little bit later. Okay, that's fine. All right, so some just quick practice here. If I want to find the number of protons and neutrons and electrons in these things, okay, so real quickly, if I run through it, quickly, okay, H and H, protons would be 1 for the atomic number. It's a neutral atom. Again, you don't see a charge in here. There's no charge up top, so that's going to tell us we're neutral. Okay, so the 1 and 1 has to be true. Okay, our neutrons would be 1 minus 1, okay, which would be 0, so no neutrons. Okay, protons would be 5. Okay, neutrons would be 6, 11 minus 5. Okay, electrons are going to be the same as protons again. Okay, and you can probably follow it all the way through here. As you can see, there's no charges on any of these things. All right, so we can go 16, we can go 16, we can go 16. We can go 17 protons, we can go 17 electrons, and we can go 35 minus 17 would be 18. We could be 92, we could be 92, and we can go 146. I believe that's correct. All right, so it would be 238. So pretty easy along the way finding protons, neutrons, electrons. And again, down here, if an element has an atomic number of 34, okay, and has a mass number of 78, okay, the number of protons would be 34, okay, the number of electrons would be 34, okay, the number of neutrons, again, would be 78 minus 34, which would be 44, okay, okay, and I believe 34 would be, had to look at the periodic table really quickly. 34 is going to be selenium, so I could actually write that out. I can say selenium would have a 78 at the top and a 34 at the bottom, right? So we can do that whole complete symbol notation. Okay, again, this is symbol notation. Okay, looking pretty good, everybody. All right, so what we're going to do next is, all right, we have our neutral atoms, we have our protons, neutrons, electrons. What happens if I change the number of electrons for that particular atom? So I'm going to keep the number of protons the same, but I'm going to change the number of electrons only, and I'll also keep the neutrons the same. So we'll keep the protons and neutrons the same, we'll change the electrons. And when you do that, you're going to have something called an ion. Okay, and this is really, really important. You got to know how to form your ions. Your ions are important stuff. Okay, so what is an ion? An ion is a charged particle where the protons or electrons are different in number. Okay, so you have different numbers of protons and electrons. Okay, and that's why you give rise to a charge. Again, protons are positive and electrons are negative. So when they're the same, you have a neutral atom. But when they're different, things happen. Okay, so the charge is going to tell you how many electrons have been lost or gained. The charge is going to tell you this. So when you lose electrons, you're going to have a positive charge. When you gain them, you're going to have a negative charge because electrons themselves are negatives. Okay, and they're actually negative ones. So think about an electron, a 1e minus is a negative 1. Okay, now how do you get an ion? Ions result when metal atoms, okay, transfer their electrons to nonmetals, okay, or you have polyatomic ions. So for example, in your little periodic table here, you're going to have your metals, again, mostly here, all right, and your nonmetals are on top here, the nonmetals. And when metals give their electrons to nonmetals is when you gain these and lose these electrons, and you result in ions. Okay, so for example, let's just say I had the oxygen atom that has a 16 at the top, 8 at the bottom, and we're neutral. Okay, if that's the case, we know we have 8 protons, right? Because the 8 is the atomic number, which gives us an 8 charge. Well, we also have 8 electrons because the 8 is also telling me that in a neutral atom because you're neutral, right? That's important. Okay, so you have a neutral atom which gives you 0 charge. Now, normally we don't write this charge up at the top. You can see that we don't have a number here. We usually leave it out. I mean, if you want to put it, you can, but normally we leave it out. Okay, now in the case up here, okay, in the case up here, what we're going to do is we're going to have 16 and 2, but what we're going to do is we see we have a negative charge up here of -2. Okay, so we still have our 8 protons. However, our 8 electrons have changed. So because we have 2 more electrons, okay, again, this is 2 more electrons, we would have to add that number to the number of protons to get -10 electrons, or 10 electrons. So we have 2 more than we would have 8. So when we check our math on this, we have 8 plus coming from the protons, a -10 coming from electrons, and that would be -2. And you can see we changed the name from an oxygen atom to an oxide ion. So this would be oxygen atom to oxide ion. Okay, so for a good example is aluminum +3. Let's see what we're doing here. Well, protons, that would be that would be 13, right? So think of that as equal a +13. And then our neutrons, of course, would be 27 minus 13, which would be 14 from before. Now, the +3 simply means I have 3 more protons than electrons, or 3 less electrons. Okay, so in that case, 3 less electrons would be 10 electrons. Okay, now again, I can always double check this by looking at the math. Okay, so that would give me a -10. A -10 and a +13 is +3, which again gives us that. All right. If we want to do for chlorine, we could say, okay, chlorine is going to have 17 protons. We can say 35 minus 17 is 18. We're not going to worry about the neutrons right now, but I do see a -1 in here. A -1 means 1 extra electron. Okay. So if I have 17 protons and a neutral atom would have 17 electrons, I have 1 more electrons than protons. I would have 18. This would be a +17. Or +17, sorry. This would be an 18 minus, I would have, add them together, -1. Okay, Mg, well, let's look at this a different way. What if I had 12 protons and I had only 10 electrons? What if I gave you down here and you had to find the charge? Again, this would be +12. This would be -10, right? And that would be +2. So that would be my charge, would be +2 if I had 2 less electrons. Okay? So again, our neutrons would be 24 like this, okay? So that would really be a good way to think about it. Okay, so if I wanted to tell the numbers of protons, electrons, and a P-3 ion, this is a little tricky because they're not giving you any information. So you would look up phosphorus and find out that phosphorus is atomic number 15, okay? Now, they don't give you any information about the top number, but they do give you a number in the periodic table that's a decimal number. So in that case, and again, we'll do a little more with this later, we would round that number to the nearest whole number, I believe, is 31. If I look really quickly at my periodic table, we can round that number to 31, and now we have the information that we need, okay? And we said we have a -3 charge. So I'm going to say 15 protons. We'll say 3 more electrons would be 18 electrons. And of course, 31 minus 15 would be 16 neutrons. Okay, if they ask you, but they only ask you protons and electrons. Okay, so a quick real review on the side, maybe we can say if you have less electrons, you're going to be positively charged. And if you have more electrons, you will be negatively charged. So less electrons than protons, more electrons than protons, you would have to be positive and minus. Okay. So if you got to go back and take a look, and again, we're going to review this as we go. Okay. In the next clip on this, what we'll be doing is talking about what happens when we change the neutrons, and that involves a little bit more of a discussion. So for now, we'll leave it right here. Okay. Thank you. Bye bye.